Hello, welcome students. In previous video we have started lesson number 16, reflection of light. Today we will study the remaining part of the lesson. Try this. See, figure 16.4a and b show three parallel rays shown in blue color incident on smooth and rough surfaces. The reflected rays drawn using laws of reflection shown in red color. See, in the picture we can see the blue colored rays are incident rays and the red colored rays are reflected rays. So, rays reflected from which surface are parallel to one another? Rays reflected from smooth surface are parallel to one another. Now we will study about the regular reflection of light and irregular reflection of light. First, regular reflection of light. The reflection of light from a plane and smooth surface is called regular reflection of light. Understood? The reflection of light from a plane and smooth surface is called regular reflection of light. And here smooth surface example is table, book, etc. For regular reflection, the angles of incidence as well as of reflection are the same for all parallel rays falling on the surface. Thus, the reflected rays are also parallel to one another. If the angles of incidence for incident rays are I1, I2, I3 and their angles of reflection are R1, R2, R3 respectively, then I1 is equal to I2 is equal to I3, which is equal to R1 equal to R2 equal to R3, means here all the angle of incidence are equal to angle of reflection. Now second one, irregular reflection of light. Reflection of light from a rough surface is called irregular reflection of light. Here rough surface means example cement road, sandpaper, etc. In irregular reflection, the angles of incidence for parallel rays of incidence are not equal and therefore angles of reflection are also not equal. That is, I1 is not equal to I2 is not equal to I3 and I1 is equal to R1 not equal to R2 not equal to R3. So, thus the reflected rays are not parallel to one another and spread over a large surface. We can see this in the picture. So, in irregular reflection of light, I is not equal to R. That is, angle of incidence is not equal to angle of reflection. Now, always remember, laws of reflection are followed in both regular and irregular reflection. The reflection of light in irregular reflection has not been obtained because the laws of reflection are not followed, but they are obtained because the surface is rough. In irregular reflection, the angles of incidence at different points are different, but at any point, the angles of incidence and reflection are equal. That is, I1 is equal to R1, I2 is equal to R2, so on. Reflection of reflected light. Can you tell? How do you see if the barber in a salon has cut the hair on your neck properly or not? In salon, there are mirrors in your front and at back. The image of the back of your head is formed in the mirror at the back. The image of this image is formed in the mirror in front of you. Thus, you can see how the hair at the back side of your head is cut. Now, what type of image do we see in a mirror? What happens to the left and right sides? The image in a plane mirror is upright, erect, and of the same size as the object, but the left and right sides are interchanged. Our right hand appears to be the left hand in the image, and the left hand appears to be the right hand in the image. So, next question. How do we see the image of the moon in water? We see, as moon is not self-luminous, the sunlight falling on the surface of the moon is reflected. This reflected light is again reflected by water to give us the image of the moon. In this way, light can be reflected several times. Kaleidoscope. Try this activity. Take 3 rectangular mirrors of the same size. Using sticking tape, stick the mirrors together, making a triangle with the reflecting surface facing inwards as shown in the picture. Take a white paper of triangular shape and fix it with tape at one end of the mirrors, closing that end. Insert 4 to 5 colored glass pieces in the hollow of the mirrors. Close the other end also with a paper and make a hole in it. Look through the hole towards light. You will see innumerable images of the glass pieces. These are formed due to reflections by the 3 mirrors. You can see different designs in the kaleidoscope. The specialty of a kaleidoscope is that the designs do not easily repeat themselves. Every time the design is different. People making wallpapers which are used to decorate walls and cloth, designers use kaleidoscope for making new designs. Periscope activity. Take a cardboard box, make slits in the top and bottom sides of the box and place the 2 mirrors so that they make an angle of 45 degrees with the sides of the box and are parallel to each other. Fix them with sticking tape as shown in the picture. Make 2 windows of 1 inch each near the 2 mirrors. Now see through the bottom window. Make note of what you see. From the bottom window, one can see what is in front of the top window. This device is called a periscope. This is used in submarines to see objects above the surface of water. It is also used to observe and keep a watch on the objects or persons on the ground from an underground bunker. Kaleidoscope and periscope both use the properties of reflection of light. I hope you have understood the topic. So for better understanding, read the topic once again and do the given homework.